All right, students of the class, here we go. So this is going to be a more challenging example of solving a differential equation. The steps basically remain the same, but what's going to happen here is you'll notice let's just read the problem because that's a good starting place. So the questions will usually read, find the particular solution y equals f of x, and that's a good phrase, right? Because it's basically saying find y, right? We want to find y, and you are given dy dx, which is y prime. And so that setup is still here. You still have the we have y prime, you want y. We're going to separate and integrate this, and it's going to be okay. Cool. And then there's this other information here at the end that, okay, we have our differential equation, we have an initial condition, and actually that is info that will be used at the very end of the problem. So you don't want to forget it's there, but we're not going to use it until the very end. Okay, so let's try it out, because it's basically the same steps, they're just in a different order and more complicated. So, no, same order, yeah. Yeah. dy dx equals, here's the difference, is that y appears on the other side of the equation, which is a new thing that we haven't seen yet. But it's going to be okay, because your first step, which is the separate step, simply has one more piece. So notice that our dx is going to move to the other side, so let's do that as the first part, and then, alright, x minus 1, check out this color swapping, I'm so pro. Okay, but the variables are not separated yet. We said that we wanted, on the equal side, you wanted all the y's on one side, and all the x's on the other. But look, you have a y on here, so you have to get rid of it. And the way we're going to do that is by getting rid of it. So it's multiplied, so we're going to divide both sides by y. Ta-da! Cool. Now we can move on to our integration step, because we've confirmed that the two sides are indeed separated. So we're going to integrate both sides, and I'm going to rewrite this because of clutter. So we have the integral, and I like to rewrite this not as a dy over y, you can do that, but 1 over y dy, because then I can clearly see what integral rule I will use. And on this side, we'll have x minus 1 squared dx. Okay, the variables are separated, we're good to go, and now we can enter step 2, which is the integrate both sides. You just want to treat both sides separately at this point, right? We've separated the variables, so we have two little mini problems here. So the integral of 1 over y dy, you got to think about that, but it ends up being the natural log of the absolute value of y plus, and I'm just going to go ahead and write c1, we have that there. And then on the other side, we do have a little bit of a u sub here, right? This u would be x minus 1, but because the du is just 1, there's no doctoring or counterbalancing, and so if I'm integrating give away the answer there, if I'm integrating u squared, because it's squared, I would simply have a 1/3, and then stuff x minus 1 cubed, and then plus c2. Okay, so that's basically the hardest part here, is figuring out what two integral rules to use. And now we're done integrating. Okay, so now my last step there is to solve for y. All right, so let's solve for y. You want to do this as algebraically as possible. So here's the y. You need to get rid of everything else. Get rid of the plus c first. This is the easiest thing to do. Trust me, I'm a math teacher. So we're going to subtract c1 from both sides. And so on this side, we'll be left with ln, absolute value of y, equals 1/3 x minus 1 cubed. And then, again, I'm just going to combine these c2 and the minus c1, and we'll just call that plus c, right? It's still a constant. And now here's where people get scared, right? Because they see ln and they're like, oh gosh, is it 0? Is it 1? Is it infinity? Is it e? I don't remember. It's okay, guys. It's going to be okay. The opposite of ln is an exponent. So what you're going to do is you're going to e to both sides of the equation. You're going to put both sides in parentheses and do e to both sides. Both sides become the exponent in your equation. What this allows us to do is say, hey look, e and ln are inverse operations. When they are directly next to each other, right, there's no constant in front, it's just a 1, we're just going to cancel these out. So nice. The absolute value still stays there. That's not the ln, right? The absolute value still stays there. And on the other side, we have e, and you need, oh my gosh, please draw these parentheses. You must draw these parentheses because of the wonderful things he does. Most people will do this. and they'll write plus c like this because, right, it's plus c. This is not correct. This is not correct. Because the plus c right here is in the exponent. Right? You did e to both sides. The plus c was on the side. It is now in the exponent. So this plus c over here is not down on the same level as the e. It is still stuck up here in the exponent. Whoops. Still stuck up here in the exponent. And you need to keep it there until you do something to bring it down. There is a way to bring it down. It works like this. Hey, you have e. You have an exponent. Properties of exponents say that you can take addition and make it multiplication. So our next line is going to say, we're going to do that. We're going to bring that down, and we'll have e to the 1/3 x minus 1 cubed, and then the addition becomes multiplication. So I'm going to say times e to the c. Okay, so the addition becomes multiplication. We have times e to the c. The addition becomes multiplication. Très bien. Okay, so the next thing is very complicated. No, it's not complicated at all. It's just math. All right. Hey, we haven't really dealt with absolute value a lot, so let's think about an easier mini problem. The absolute value of x is 5. What are the solutions? You've known this since a long time ago. It's just plus or minus 5. This is how you get rid of absolute value. You take the other side and you make it plus or minus. That's it. So what we're going to do is we're going to say, hey, y equals plus or minus. I know, it's that simple. And all these years, you thought it was so complicated. But it's not. So it's just plus or minus e 1/3 x minus 1 cubed times, that times e to the c is still there. Okay, and now we're almost done. We're going to collect all the terms, and notice something here. This is really cool, and it makes problems a lot simpler. C is a constant. E to the c, e is a constant, right? It's like 2.7. C is a constant, e is a constant, and plus or minus. So all of that stuff that I just highlighted in yellow, plus or minus e to the c, that's all just a constant. We're going to call it k for constant. Yeah, very good. Okay, it's all just a constant. So it's just going to absorb all the constantness, and that's okay. Right? When you go off and become a professional differential equation solver, you're going to do that because it makes your equation a lot simpler, right? Do you want to work with this equation, or do you want to work with this equation? This one is much simpler. We're going to deal with this one because it's easier to look at. Oh, wait. Oh, are we done? No, we're not done. You need to be careful. We still have a c in our problem. We need, however, the particular solution, and that's where this initial condition comes in. All the way at the end. You're all the way done, you did all the hard part, and now what you have to do is plug in, this is like step 4, it's the last step for a particular solution. You're going to plug in the initial condition to solve for k. We got to solve for k. Okay, so we solve for k. Notice over here that we have an x and a y. X is 0 because it's in the f of x. X 0. Y is 2. So we're going to plug in 0 for x and y is 2. So keep the colors going. 2 equals k e 1/3 0 minus 1 cubed. Cool. Alright, now we're going to solve for k. We're going to simplify all this stuff. K will have e in it. That's okay, guys. It's going to be okay. It's just e. It's just a number. It's like pi. Okay, so over here, this 0 minus 1 is just negative 1. Negative 1 cubed is still negative 1. So that's going to make this e to the negative 1/3. That simplifies e to the negative 1/3. And when I move that over to the other side, I'll get k equals 2. Oh, that's the bell. Alright, hold on. Okay, we're back now. So we found the k value, and the k value was 2, and then when we move the e over, we can simply make the exponent positive. That's one way to think about it. So e to the positive 1/3. Remember that e to the negative 1/3 is negative. Sorry, nope, it's not negative. It's 1 over e to the 1/3. So I'm simply just multiplying both sides by e to the 1/3. And now we're almost done. The only thing we have left to do is to rewrite our equation with the new k value. So when we do this, we'll get our final answer of y equals, and then I'm plugging in k, so 2e to the 1/3, and then we have all the rest of the stuff. So e to the 1/3 x minus 1, I'm forgetting my colors here, third. And that is the particular solution. So that's the process. It's a little long, but it's okay. Again, you're going to separate the variables, integrate both sides, solve for the y, and then you're going to plug in your initial condition to solve for the c or the k or whatever variable you choose. Yeah, come to class with questions and we'll be good to go.